I can graph that first line because I know slope-intercept formula, but in this exercise, they're asking me to just plot points. Plug in some x's, get some y's that go in it. Now, all of these are lines, so how many points do I really need to plug in to get these? Just 2 would be fine. If I had 3, it would be better because I could make sure that I, got the, I didn't mess up when I plugged my numbers in. Okay, so if I'm looking at the first one is y equal x plus 5. What they're asking me to do here is just pick some easy values. Wouldn't 0 and 1 be easy x's to pick and plug in? I could use my graphing calculator, but it's almost easier not to here. What's 0 plus 5? 5. And if I plug in x equal 1, 1 plus 5 would give me a y of 6. So if we graph that 0, remember this is your x-axis here. The x value tells you where to go on your x-axis. So at x is 0, we're here at the origin, and then they want me to go up to y is 5. That means that point would be right here, wouldn't it? And then the second, if x is 1, y is 6. Here's 1. If I go up to where 6 is, there's the point right there. Those 2 little red dots on the bottom, that was me just trying to find the x. Are those real points on the graph? No. Okay, so don't think that there's two points or anything. Those are my 2 points. That was just helping me find x is 1, y is 6. So if I graph that point, if I graph that, I'm going to go ahead and add some more in just so I draw it better. We just connect them. Okay, so that's the first one. So if you start off with y equal x plus 5, if you notice what they do next on number 2, they want us to graph y equal 2x plus 5. What did they do? What's the only difference between this red equation and this blue equation? Between A and B?
Is that 2x negative?
Okay, it's B in your book. It's B in your book. I'm going through your book. Y equal 2x plus 5. This thing doesn't always pick up unless I put it on such fat writing that it's going to fill the whole page up. They just added, what now, the 2 in front of the x, didn't they? If there wasn't anything before, it's a 1. It's an invisible 1, right? So if you notice, they still have plus 5 on the end. So we still have, if you think about this, we know that that's the y-intercept. If we didn't know it, though, we could get points. Let's plug in x is 0, because that's where my y-intercepts are, where x is 0. 2 times 0 is 0, plus 5 is 5. So we're still at the same, when we compare y equal x plus 5 and y equal 2x plus 5, we still have the same y-intercept, don't we? But let's pick x equal 1. 2 times 1 is 2, plus 5 is 7. So let's find 1, 7. It's right here. I'm going to kind of fill in a little bit more points just so I can draw mine since I can't use a ruler to do it. What did putting a 2 in front of the x instead of a 1 do to that red line? It made it what now? Yeah, it's a steeper slope is how we would say it. It's a steeper slope. It made it steeper, okay? So I'm just going to keep graphing in different colors. C has me bringing up 1 more. Now it's like y equal 3x plus 5. So they took it from the number in front of the x being 1 to 2, and now they're putting a 3 in front of it. If we plug in x is 0, we still get 0, 5, don't we? You see how all these things ended with plus 5, and they all have the same y-intercept, because that's where the y-intercept is, isn't it? Let's plug in x is 1. When x is 1, 3 times 1 is 3, plus 5 is 8. So let's graph 1, 8. Oh, it's right there. What did putting a 3 in front of the x do in comparison to the other ones? What's different about the green line to the red and the blue ones if you compare them? It's even steeper slope. So the higher the number we're putting in front of the x, the steeper the line gets. This is, again, just kind of getting you to think about how a change in pieces of that equation, what does it do to the graph? All right, now they're going to do, let me copy this. Let me just we'll keep going for a little while. D, how did they change D? Look at that one. Y equal negative 2x plus 5. We already graphed 2x plus 5, didn't we? What's the only thing different here?
Negative 2x.
Yeah, the negative is going to make the slope. So we're going to have, if you look at 2x plus 5 and y equal negative 2x plus 5, they will have the same steepness, but one will be rising and one will be falling, okay? The slopes that we have on here so far, these are all going, if you read slopes, you read graphs from left to right, just like you read a book, left to right. So from left to right, aren't these all, like, look at the red line. Isn't it climbing from left to right? It's getting higher. So we would say that's a positive slope. What we're getting ready to graph now is a negative slope. So let's see, if I plug, let's plug in a couple of points. If I plug in x is 0, negative 2 times 0 is 0, and 0 plus 5 is 5. So we still have the same y-intercept on this because, again, look, all of them have plus 5 on the end, don't they? But if I plug in 1, just to get a quick little graph, negative 2 times 1 is negative 2, and negative 2 plus 5 is 3, okay? So I've got the point now, 1, 3. So let me try to do that. You're doing this on your paper too. So do you see that putting the negative out front caused it to be falling from left to right? The others were rising from left to right. They were positive slopes. This has a negative slope. It means it falls from left to right. On E, I'll pick like this icky green here. On E, now they've got y equal 2x minus 5. What did they change here? What kind of slope do we have first? Y equal 2x minus 5. It's a positive number, so I know it's going to be going up from left to right. That's one thing I can say. When I see a positive number in front of the x, I know it's going up from left to right. It's a positive slope. So let's graph some points. Do they have the same y-intercept on this one? Yeah, now it's negative 5, isn't it? So my starting point would be negative 5 if I were thinking slope-intercept form, or I could plug in if x is 0, 2 times 0 is 0, minus 5 is negative 5. And let's pick 1 again. That seems to be working pretty well. 2 times 1 is 2. 2 minus 5 would be negative 3. So my point at 1 is now 1, negative 3. There was a positive 2 in there in front of the x for the slope, and again I have a positive slope again now but the y-intercept, when you put a negative on the y-intercept, that's a totally different starting point, isn't it? And I'll do that one, it's kind of pink. And so F is the last one. Y equals 0x plus 5. Hey, we got a 0 in front of the x now. What's that going to do? Let's see, okay? Let's just see what happens. If I plug in 0, 0 times 0 is 0, plus 5 is 5. So there's the same y-intercept as we had earlier, right? Now it looks pink. Let's plug in x is 1. If x is 1, 0 times 1 is 0. Plus 5 is, 0 plus 5 is 5, right? If you're using your table of values, you don't have to worry about this. We're just kind of doing it, by hand since we can. So that's the 0.15. Look at this when we join them. What we get? Horizontal line. What was our slope there? It was 0 because it's the number in front of the x. Would we normally write 0x plus 5? Would the lazy mathematician write 0x plus 5? No, it's, yeah, you just write y equals 5. That's why, that's why those equations look that way. We could write them in slope-intercept form like that and put a 0 out front, and sometimes we wish we did just because it would help us see that the slope is 0 there. But lazy mathematicians go, too much work, I'm not going to move my hand that much, so they're going to write y equal 5, and that term dropped out, didn't it, because it's being multiplied by a 0. So 0 slopes, when you have a horizontal line and it has 0 slope, it can actually be written as in slope-intercept form, in that y equal mx plus b form. It's just that we normally don't do it because, that's a term, 0 times anything is 0. We just don't write it down.